Hi everyone, welcome back to Tech Jaala. My name is Abhishek, and in today's video, we'll be diving into a very exciting topic, creating and consuming APIs using Python. But first, let me give you a quick overview of what we will be covering in this video. We'll start by understanding what an API is. Then, we'll jump into creating our own API using Flask, a popular Python web framework. After that, we'll use the request module to interact with our API. By the end of this video, you will have a solid understanding of how APIs work and how you can create and use them in your Python projects. So, without further ado, let's get started. API stands for Application Programming Interface. It's a set of rules and definitions that allows application to communicate with each other. Think of an API like a waiter in a restaurant. Imagine you are sitting at a table with a menu of choices to order from, and the kitchen is the part of system that will prepare your order. You can't directly tell the kitchen what you want because you don't have the right interface to do so. Instead, you communicate your order through the waiter, who acts as the messenger between you and the kitchen. The waiter takes your order, tells the kitchen, and then delivers the food back to you. Similarly, an API takes your request, tells the system what you want to do, and then returns the response back to you. When working with APIs, we use various HTTP methods to interact with resources. The most common methods are get, post, put, and delete. Let me explain each of these methods using our restaurant analogy. Get, used to retrieve data from the server. It's like asking the waiter to bring you a menu so you can see what dishes are available. Post, used to send data to the server to create a new resource. It's like giving the waiter your order so the kitchen can prepare a new dish for you. Put, used to update an existing resource on the server. It's like telling the waiter to change an item in your order before it gets cooked. Delete, used to remove a resource from the server. It's like telling the waiter to cancel your order before it gets cooked. To start, we'll create a simple API using Flask. Flask is a lightweight WSGI web application framework in Python. For that, first we have to install Flask. Pip install Flask. Now once we installed Flask, let us create a simple Flask application. I'll create a file named app.py. Now let me import the Flask. From Flask, import Flask. The Flask is the main class used to create an application. Then let me create an instance of the Flask. Then we'll initialize the empty list to store the post. We will be creating a simple API landing page. This line of code is a decorator that tells Flask what URL should trigger our function. In this case, it's the root URL represented by a /. Next, we'll define a function named home. This function will handle the request and return the content for our home page. That is, this home function will be called when the root URL is accessed. The render template string function allows us to embed HTML code within our Python code. This HTML content includes a basic structure with a title, heading, and a description of our API endpoints. Finally, to see this in action, we'll run our Flask application. Once we execute app.py, now open your browser and go to localhost 5000 port. You will see the landing page we have created. Now, let's move on to creating our first API endpoint. This endpoint will allow us to retrieve a list of posts. Here, we are defining a route with the URL /post. The methods equal to get part specifies that this route should only respond to a get request, which is the standard HTTP method for retrieving data. Get requests are typically used to fetch data from a server, and that's exactly what we will be doing here, retrieving a list of posts. Next, we define a function named getPost that will handle the get request and return the data. In this function, we are using Flask JSONify function to convert our list of posts into JSON format, which is the standard format for API responses. The status code 200 indicates a successful request, meaning the server was able to process the GET request and return the data without any issues. So, when a client makes a GET request to the POST endpoint, our Flask app will respond with a list of posts in a JSON format and a 200 status code, indicating that everything went smoothly. Next, we'll create a POST endpoint that will allow users to add new posts to our API. Just like before, we'll start by defining the root using the @app.root decorator, but this time we'll specify the post method. Here, we are defining a root with the URL/post and specifying that this endpoint will handle post requests. Post requests are typically used to send data to the server, often to create or update resources. The add_post function will handle the incoming post request and add the new post to our list. In this function, the first thing we do is to retrieve the data sent in the post request using request.getJSON method. This method extracts the JSON data from the request body and converts it into a Python dictionary. Once we have the new post data, we add it to our existing list of posts using append method. Finally, we return the newly added post in JSON format along with an HTTP status code 201. So, when a client sends a post request to /post with a new post data, our Flask app will add the post to the list and return the newly created post along with 201 status code, confirming that the operation was successful. Now, let's move on to creating a put endpoint. This endpoint will allow users to update an existing post. Here, we define a root with the URL /post/post ID. The post ID part is a root parameter that captures the post ID from the URL and passes it as an integer to our function. The method equal to put specifies that this endpoint handles put requests, which are used to update the existing resources. By adding int:post_id to the root, we are telling Flask to expect an integer value in the URL, which will be used to identify the post that needs to be updated. Next, let's define the updatePost function, which will handle the put request. This function will take the post ID from the URL and the updated data from the request body. Inside the function, the first thing we do is retrieve the updated data sent in the put request using request.getJSON method. This method extracts the JSON data from the request body and converts it into a Python dictionary, just like we did with the post request. We store the updated post data in the post variable, which we will be using it to update the existing post. This conditional statement checks if the post ID is out of the range, indicating that the requested post doesn't exist. If that's the case, we return a JSON object with an error message and 404 status code, which stands for not found. Here, post of post ID equal to post updates the post at the given post ID with the new data that was sent in the request. This replaces the old post with the new one. Finally, we return the updated post in JSON format along with the 200 status code. So, when a client sends a put request to /post/post ID with updated data, our Flask app will check if the post exists, update it with the new data if it does, and return the updated post along with 200 status code, confirming the operation was successful. Finally, let's create a delete endpoint that allows users to remove an existing post. Just like before, we'll start by defining a root using @app.root decorator and specifying the delete method. Here, we are defining a root with the URL /post/int post ID. The int::post ID is a root parameter that captures the post ID from the URL and passes it as an integer to our function. The method equal to delete specifies that this endpoint handles delete requests, which are used to delete resources from the server. Next, the deletePost function will handle the delete request. This function will take post ID from the URL and remove the corresponding post from our list. This conditional statement Check if post ID is out of range, indicating that the requested post doesn't exist. In that case, we return a JSON object with an error message and 404 status code, meaning not found. If the post ID is valid, we proceed to delete the post from our list using pop method. Here, post.pop of post ID removes the post at the given post ID from the post list. The pop method is a simple and effective way to remove an item from a list by its index. Finally, we return an empty response with a 204 status code. The empty string represents that no content is being returned in the response, and the status code 204 indicates that the operation was successful, but there is no content to return. This is a standard practice for delete request when the resource has been successfully deleted. So, when a client sends a delete request to /post/post ID, our Flask app will check if the post exists, delete it if it does, and return a 204 status code to confirm that the post was successfully removed without sending any content back. Here we have finally defined our Flask application with the endpoints for CRUD operations. The /root serves as a basic HTML landing page, and /post endpoint handles get, post, put, and delete requests. Now let's interact with our API using request module. For that, first we have to install the request module. Pip install request. Once we have installed the request module, we'll make a get request to retrieve all the posts. We use request.get to send a get request. The response object contains the data returned by the server. We use response.json to parse the JSON response. Let me execute this. As of now, we don't have any post to show, so only we are getting the empty list. Next, let's create a new post using post request. Here we use request.post to send a post request to our API endpoint. The data dictionary contains the data we want to send. Using the JSON parameter, we send this dictionary as a JSON in the request body. Let me execute this. Now we can again make a get call to our API to check whether we have posted this data to our API. I'll show you in a browser now. /post. Next, same thing we can achieve using a request.get method. Yes, we can now see that we have posted the data to our API. Now let's make a put request. Let's update an existing post using put request. In this example, we use request.put method to send a put request to our API endpoint. The updated data dictionary contains the new data for the post. Using the JSON parameter, we send the dictionary as a JSON in the request body. Let me execute this. The body and the title of our post is updated. Same thing we can see in the browser as well. Finally, let's delete a post using delete request. Here we use request.delete to send a delete request to our API endpoint. Let me execute it. A status code of 204 means the post was successfully deleted. Now let me try to make a get call. So if I execute this, earlier we had this content, body and title, but if I execute this, now I have nothing. That means the post has been deleted. This is how we can make a delete call. In this video, we have learned how to create a simple API using Flask and how to interact with it using request module in Python. We have covered the 4 main HTTP methods: get, post, put, and delete. Understanding this concept is essential for building and consuming web services. Thank you for watching, and don't forget to like, share, and subscribe to Tech Jaala for more programming tutorials. See you next time.